Hello and welcome everyone to a brand new series on the channel where I'm going to teach you potatoes how to program. Um, we're going to try to keep this simple but also fast. I'd like to get you guys making some actual fun things within probably a couple of hours, so let's see if we're able to do that. The first thing you're going to need is an IDE, or Integrated Development Environment, for those who need to word things out. For C#, you're going to be probably using Visual Studio. You can also use Visual Studio Code if you're comfortable setting up a project yourself. Probably not if you're new. Just get Visual Studio. It's free. Just get the Community Edition. It'll have all of your fun things like finishing your lines for you. You can even get plugins like Copilot for it. I'm going to be using JetBrains Writer. I just prefer it, but I'll show you guys how to set up in Visual Studio. So for this, we're going to be starting very basic. After you install Visual Studio, you should be able to open it. You're going to have a list like this, except it'll be empty because you haven't done anything before, unless you have, in which case you should probably skip ahead a little bit. Unless there's no videos yet. You're going to hit Create a New Project, and you're just going to keep it nice and simple. You're going to choose, oh, it has a search right there. I'm just blind. So if you search console, you should have console app. You do not want to use .NET Framework. That is an old bygone era. Trust me, just the one that says C# console app, that's the one you want. Then you're going to hit next. You're going to name it whatever you want. I'd name it like learning. And then you hit next and it'll open it up. I'm going to do the same thing. I'm just going to do it in JetBrains Writer instead. So I'm going to do my console application. I'm going to call it learning. And then I'm going to use .NET 7. If it asks you, just do 7. 8 is a little fresh out of the oven, so we're going to use one that's a little bit better supported. C#, everything else you can just ignore, and you can just create a project. And this should give you a super bare bones project. It really is that simple. On your left, whether it's Visual Studio or Writer or whatever other IDE you're using, you probably have a list of all of your files. And you should start with a very bare bones block here. Now, something I'm not a huge fan of is that in newer versions of C#, and let me expand this so you can really see it. Newer version of C#, they kind of start you out with this empty template. I'm not a fan of this because it doesn't really help you understand how a program actually works. In something like Python, this is really common. You can just start writing code, but I think it's more important for you to understand the structure of a program. So the first thing we're going to do is we're just going to delete everything here. And now we're going to write some things that we're going to explain in the future, but you just don't have to worry about right now. I'm not going to get you off track worrying about things you're not ready for. So you're just going to write public class program. Then you're going to do brackets. And then inside of those brackets, you're going to write public static void main. And you can see Copilot is trying to help me out here. And inside of these parentheses, you're just going to do string args with square brackets. And then another set of brackets. Why did I have you do this? Well, you see, a lot of languages are trying to become simpler. And so technically, if I don't have any of this, I can just start writing code. I can do whatever I want. But it's good to know that that is actually secretly doing this in the background. The compiler is basically putting this in. You just don't know it's there. This is actually where your program opens. These arguments are, if you've ever run something on a command line before, when you give arguments, when you type things into the command line, for example, you might type into the command line, what's something you do? Like ping 1.1.1.1 because you want to ping 1.1.1.1. 1.1.1.1 is an arg. It would go into here. So this is really where your program opens. And for something like opening a file, the location of the file you're opening for the app would go into the arguments. That's how programs work. It's pretty cool. So we can take information in when the program is run. And then this is actually what fires immediately. It's called a function. We'll get into functions later. But all that matters is that you have something that looks basically like this. And now we can do the most brilliant thing in the world. You can call yourself a programmer directly after doing this. You can go ahead and write console.writeLine hello world inside of your quotation marks. Make sure they're double quotes. C# cares. Double quotes and single quotes are different things. We'll go over that too. Just don't worry about it right now. And then in your IDE, you should be able to hit play. If for some reason you're doing this and you just want to run it and you're using Visual Studio Code or something, you can also write .NET run in your terminal and it should run. Unless it asks you to give it the project. Really? It can't guess? It can't guess from here? Oh well. Anyways, for our purposes, we're just gonna hit the run button. It looks like a play. In Visual Studio, it'll be like in the middle of the top. It'll also have a play button. And then you can hit that and you should see in your console, it should say hello world, which incredible. It outputs something. So I went ahead and I changed my theme so it'll look like Visual Studio like you guys are using, just so that the colors don't confuse you. The color coding in an IDE does actually mean things, but we'll go over that later. So you have successfully written hello world to the console if you've written this. That's basically the first thing everyone does in a programming language, but let's get a little bit more complicated. Let's go ahead and get into variables. So C# is a statically typed language. What that means is that you have to know what type of an object you're putting into a variable. So for example, if I were to get a piece of text, I could do something like saying string hello equals hello world. Now, when we do this, let's talk about what you're actually doing, because this is one of the things where it's easy to copy text, but actually understanding what's happening under the hood is incredibly important. And due to my recent advancements in my setup, we can whiteboard this. Watch this. Whoa, it's a black square. But that black square can show text, which I will be using to demonstrate. So when you make a variable like this, string hello, what you're really doing is you're making a box. All right, so we've got a box. That is our variable. Now we are calling it hello. We have named it hello. So we have a box, we're calling hello. Now string here, the first thing we say is actually, and let me move this over a little bit so that you can actually see the code. String is saying what is in the box. You know, when you have boxes in your house, it's very unhelpful if you're packing and you never label anything and you don't know what's in the box, because you may open it up and it may be Christmas ornaments, it may be kitchen utensils. It's really nice when you are especially moving one place to another that you know what's inside of boxes. And it's the same thing in programming. We want to know what type of a thing is in our box. Some languages like JavaScript don't require this, and that is a discussion for another time. But in this case, we have labeled this box and we have said, okay, it contains a string. And what string are we putting into it? We are putting hello world into the box. Actually, let's do the arrow in blue because we have amazing multiple color technology. Now, we have put hello world into this box. So now that hello world is in the box called hello, we can do something pretty crazy. Instead of saying console.writeLine hello world, we can say console.writeLine hello. And now, if we hit play, it's going to do the exact same thing as before. It's going to say hello world, as you can see on the bottom. Now, the reason why this is important is because you can change what's inside of the box. Whereas if I just wrote console.writeLine hello world, that can only say hello world. But now that we have used a variable, this could potentially say anything. It's important to realize that when you create a variable, you are actually getting, in your computer's memory, a location. So let's say this blue box represents all of your computer's memory going in order. You are actually taking a location of that memory and you are assigning it the name hello. And obviously it knows that it is a string that you are storing there. But it's very important to realize that you are physically taking a location memory and shoving something in there so that it can be referred to again in the future. All right. So because we now have this variable hello, which I've already said we can change what's in it. That's called mutability, by the way. It's mutable, which means you can mutate it, and mutate means to change. There's a lot of terms for things in programming. You don't really need to know the terms, but people will think you're cool if you know the terms. So we're going to mutate hello here. We're going to go ahead and we're going to take hello, and we set it equal to hello world to start. But now we can do hello equals hi there. And actually, I'm going to make this go after this right line here. And then I'm going to do console.writeLine hello a second time. Think to yourself what should happen when we run this. You probably understand what it's going to do, but think about what it's actually doing. We already know that console.writeLine is going to write a line to the console, or at least I hope you figured that out at this point. If not, don't worry. That's what it does. We take what's in hello and we write it to the console. So let's think about, again, what this is actually doing. We have inside of a box hello world. And now that we understand the box analogy, I'll just get rid of the whole thing. All right. So now we'll use this square to represent it. So this square, we are putting in hello world. We're then asking the console to write what is inside of the box. So the box is going to go into console.writeLine and it's going to output hello world. Then we are going to get the same box and we're going to put hi there inside of it. And then once again, we're going to give the box to console.writeLine. Now this may seem extremely simple, but it's important to understand the concept. So I'm trying to beat it into your head. It is the same box. It is simply having the contents replaced. So if we're replacing the contents, the old contents are gone, the new contents are there, and so when we press play, it's going to say hello world, and then hi there, in order, because that's the order we did it in. All right, so that's all very exciting. Now, there are some shorthands we can use. You're actually going to notice that right here, there's a little bit of green under here, which means that my IDE is telling me that I can actually make this a little bit cleaner. In C#, you can basically do something called inferring types. I can say var hello instead of string hello. I can do this because the compiler knows that this is a string because it's in double quotations, and so it can guess that this is going to be a string. However, I can't do something like this. I can't just declare that there's a variable named hello because I haven't given it an equals, so there's no way for the compiler to know what it's going to be. It'll be angry because technically it'll know at this point what it is, but here it has no clue. So if I'm going to not initialize my variable, and initialize meaning give it a value, I have to actually say what it is. And this will still be angry because it knows that I haven't given it anything. Hello, the box is empty. So when I tell it to write hello, it's going to throw a fit. All right. And actually, I'm going to do one further thing because we have nullables on. Actually, I'm internally debating whether or not we should do this with nullables on or not. I'm going to say no because it's better if you understand without that trigger. So if you right-click on your project, which should be on the right, and hit Properties, actually, the project's going to be the one under it, not the top thing. That's the solution. And then hit Properties. There should be something. It's going to be the same in Visual Studio that says nullable reference types. I'm disabling that. What that means is it'll check. Basically, you have to state if things can be null or not, but that's only become a thing recently, and a lot of old code you run into isn't going to have that. So it's better if you learn how to do it without it, and then in the future, if you want to try it, go right ahead. You probably have no clue what I'm talking about, but there's a little tidbit. All right, so let's get a little bit more complicated here. So we now know how to declare a variable, how to write that variable to the console so that we can actually see, what it is, how to change it. But let's talk about different types of variables because that's important. There's different types of things. As you can probably tell from the first thing we did here, a string is a string of letters. Literally just strung together. You can think of it as a bunch of letters just stuck in a row, and it represents basically text. Now, strings are actually made out of things called characters. So, for example, if I did char A equals hello, this would get angry because it's a character and I can only do one. If I hover over it, always remember in any IDE, you can pretty much always hover over the error and it'll tell you why there is an error. For example, this is cannot convert initializer type string to type char, which is true. You cannot convert a string to a character directly. But if I were to say char A equals A, it's happy. Notice this though. I used a single quotation instead of a double quotation because in C#, a single quotation means a character and a double quotation means a string. This is just one of those things you're going to have to remember. You're probably not going to be working with characters too often, but you will. You will. Not as much as strings, but you will. Now, there's other data types as well, such as the world-renowned integers. For example, integer x equals 100. An integer is a full number. If I try to do something like .0, it's going to get angry because that's not an integer. Then there are floats. Floats are pretty cool because they can have decimals, but they're not 100% accurate. They lose accuracy when you get further and further down. So if I did something like 0.01, this is not going to maintain this. It's going to drop it. It doesn't quite round. You can look up a video on how floats work. They use something called a mantissa. They're very intelligent. The way they were built is very smart. They can hold very small numbers and very large numbers, but they aren't guaranteed to be 100% accurate. So in something like rendering or a video game, the location of your character, it doesn't matter if you're off by like a billionth of a meter. Nobody's going to notice. You can use a float. But if you're doing something like handling money, you're going to want to use something like a decimal. And a decimal is shown with an M, whereas a float has an F at the end. But a decimal is kind of perfect in that it keeps all of the accuracy, whereas a float does not. So for money, decimals would make sense. A double is like a float, but it has more accuracy. So if you need a little bit more accuracy, a double isn't a terrible idea. And then a long is like an integer. However, it can be a lot larger and a lot larger in the negative direction. All right. So in memory, you have to store your variables. This is a slightly more complicated thing to think about, but it's important that you really understand it. So when you have a variable, let's say our integer x, that is a y, now it's an x. An integer in C# has 32 bits. A bit can either be 0 or 1, but having 32 bits available gives us a limit to how large the number can be. Every position in a number, at least not floats, they work differently, but for example, in an integer, every single place, there's 32 bits, so this will just keep going this way. But the first spot, which can be 0 or 1, is worth 1. The second is 2, the next is 4, the next is 8, the next is 16. So basically, if we wanted to represent the number 3, it would just be 0, 1, 1, because 1 plus 2 equals 3. This place plus this place. If we wanted to represent 7, we just turn 4 to a 1 as well. The thing is, the way that binary works, as you can probably tell, if adding one more bit doubles the amount of possible represented values, then it's very easy to determine the largest value possible. But just as a little trick to show you this, if you add all of this together, this is actually going to be 16 different values, 0 through 15. And then, that is a disgusting 15. And then the next value is 16. So that plus that is going to be 32. So basically, if you want to know how many different values you can represent with an amount of bits, you just do 2 to the n. It's really that simple, where n is the amount of bits you're dedicating. Very, very simple. Now, don't let this math scare you away, because you could still program if you don't understand this, but it will help you, so do try to understand how memory works. So the idea is that an integer has 32 bits dedicated to it, which means that the computer's setting aside 32 bits, or 4 bytes, a byte is 8 bits, when you declare an integer. That can go all the way up and down to int.max value. It's in the billions, but there are numbers we use in the world that are a lot larger than billions. And it also goes down to negative 2.14 billion as well. Now, if you wanted to be able to go a little bit higher and you didn't have to depend on negative numbers, you can actually use a uint, which is an unsigned int, which means that it can't be negative. That means it can go twice as high because one of the bits is used to denote if it's positive or negative. So freeing up that bit means you can double the amount of values that are possible. So if I do uint.max value, you'll be able to see that, yeah, this one can be 4.29 billion max, but that's still not that big of a number. However, a long has 64 bits available to it, unlike the integer's 32 bits. So the long's max value is way larger. Way larger. This is a number that is large enough that it will almost always be enough. Almost always be enough, okay? But it uses twice as much memory, which means it's slower and it consumes more RAM when you're using them. Okay, so those are some basic data types. May not seem super basic, but those are some. The last really important one is probably the Boolean, which in C# you refer to as bool, and it can either be true or false. Yep, it can either be true or false. That's it. Very useful. Very, very useful indeed. So we can do some fun things. For example, we can say integer x equals 5, integer y equals 5, or we'll make y 10. Then we can do integer z equals x plus y. And then we can do console.writeLine z. You probably know what this is going to output. And as you expected, it outputted 15 because we can do basic math on this channel, I hope. And as before, you could technically replace these with var, but I'm going to be typing things explicitly. All right, so I think that's a good amount for our first real video. This is a pretty long video just trying to explain this very basic variable stuff, but I hope you understand at least how to declare a variable. You can kind of see that we can manipulate them, we can assign them, we can reassign them to new values, and we can print it out to the console. All right, thank you for watching. Leave a like if you enjoyed. Let me know in the comments if there's anything I can improve, because this is my first time showing how to code like that. This is actually not my first time, but first time in a while. So let me know how you feel, and I'll see you all next time.